Hello everyone, this is Karthik. So I'm gonna present about the medical insurance price prediction. Machine learning is a technique used to predict medical insurance prices. Machine learning algorithms examine large data sets to forecast health insurance premiums. These algorithms look for patterns and correlations by considering different variables such as age, gender, smoking status, and BMI, etc. This data-driven strategy improves healthcare industry efficiency by assisting insurance companies in more precisely determining insurance premiums and customizing policies to meet the needs of each individual. In this case, ML application signifies a move towards a more individual insurance pricing. This method offers a more nuanced and fair way to determine insurance costs. Medical insurance is essential because it protects people from exorbitant medical care expenses. It considerably lessens the financial burden on individual by paying variety of costs, including hospital stays, therapies, and prescription drugs. This protection is crucial because it guarantees access to necessary medical treatments without the burden of prohibitive costs, particularly in case of emergencies or from chronic conditions. Coming to the data set, I have taken the data set from the Kaggle as mentioned in the link in this slide. The size and shape of the dataset will be the 51 KB and it consists of around 1388 rows and 7 columns or features. The time period of the dataset will be the 2012 to 16, and the dataset contains the below mentioned columns like age, sex, BMI, children, region, and expenses. In this slide we have attached two screenshots. On the left side it's the data info, like whether the data has no null values and what type of data types we use in the data, and on the right side it's a description of the data, so how much is the count of the total data and mean and standard deviations. Based on the data used, I have created some of the exploited data analysis. Here is the first one, which we can see the pie charts on how the data is distributed between males and females in sex, whether the individual is a smoker or not, and how the data is divided into different regions. As you can see from this slide, the sex and region pie charts are equally distributed when compared to the smoker pie chart, which is around 80 to 20% ratio. In this slide we can see the bar graphs, which is a comparison between the expenses paid between different groups. As you can see in the first bar graph, males pay slightly higher expenses than the females do. When it comes to the smoker bar graph, if the individual is a smoker, then he pays way more higher than the individual who isn't a smoker. And the remaining two bar graphs have roughly the same prices, which is the children and the region graphs. Coming to the next slide, I have created a scatter plot for the expenses paid between the ages and BMI respectively, as you can see it here. So here there is a definite distinction between the fees that smokers must pay. Additionally, we can see that the premium cost increase along with an individual advancing years. I have developed multiple regression models, and these are the two results, which is a linear regression and SVM results. As you can see, the linear regression trend score will be the 0.729 and SVM trend score will it's on minus, and the cross validation score will be 0.74 for the linear and SVM will be the minus 0.13. I have extended it to the sum of models, which consists of random forest regressor, gradient boost regressor, and XGB regressors. These are the results that displayed with the trained test scores and the cross validation scores respectively. I have created a table for all the regression models that I have used, like the train accuracy, test accuracy, and CV scores. So out of all these models, I think XGB regressor has the highest accuracy for all the parameters, which gives you consistency in predicting the expenses in future. In this slide I have predicted the model using XGB regressor, and you can see the price is predicted for the age of 19 and the sex is male, and he's a smoker with northeast region. In conclusion, the potential of advanced analytics in healthcare insurance industry is highlighted by investigation of medical insurance premium price predictions using different machine learning models. To balance learning and validation with a variety of models, each with their own advantages, including SVM, XGBoost, a random forest, gradient boosting, and linear regression, we train on an 80-20 split ratio. This methodology yielded valuable insights into the key variables impacting insurance expenses and illustrated the potential of machine learning to improve the operation efficiency of insurance premium forecasts. Uh, the study findings highlights how machine learning is revolutionizing the cost of health insurance. These models' capacity to work with intricate high-dimensional datasets reveal subtle patterns highlights their importance in creating more precise and customized insurance quotes. It shows the possibility for a more sophisticated approach in the insurance business and helps insurance providers manage risk while also promising more fair and data-driven pricing for customers. And that will be the end of my presentation. Thank you.